Hey y'all, let's take a look at some more uniform motion problems. Let me just wipe out that curse word and put something a little more pleasant there. Okay, that sounds a little better here. Okay, let's go back to the oldie here. And let's remember to solve these things, you already know how to do those four equations to start substituting, stick stuff in there, and then, oh yeah, I substituted and I found out all the different parts of it, okay? Your only job, is to find four of your own equations from this little paragraph. And just keep at it. Even if you're not getting all four equations, don't sweat it at first. Eventually it'll start coming to you. You know you need a time, you know you need a rate, you know you need a distance, and you know you need a fourth one, whatever that is. And it'll always come up there. But let's go and do an old one. The math students jogged to class from Chick-fil-A at 2 miles an hour. And this is, if you're a visual learner, this is a great way to draw pictures. So here are the students, they jog to class. Okay, they go, and they go there, and there's class. Okay, and of course this is a math class, so it's a very happy building. Okay, there we go. And a little chimney going on there and stuff like that. Okay, there we go. All right. They jogged to class. Okay, so they're jogging that way. They drove back at 12 miles an hour. So, doink, and there we go. And then they drove back. Okay. Well, you tell me first off, what are the distances compared to each other? Same, right? So we're assuming they drove the same way they jogged to class. Okay. How long was their jogging time? If it was 5 hours longer than their driving time, blah, 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 how far was it, and so on. Okay. Well, let's just we just got to figure out four equations, right? So they jogged to class from Chick-fil-A at 2 miles per hour. What are you doing leaving Chick-fil-A? Shouldn't be doing that. Anyway, okay. So they jogged at 2 miles an hour. So immediately you go, okay, the rate of jogging is 2. That's one equation. 1 down, 3 to go. They drove back at 12 miles an hour. So you tell me what's that? They drove back at 12 miles an hour. Time, distance, or rate? Which one? Okay, yes, the rate of driving was 12. Okay, now we need a time and we need a distance. Okay, how long was their jogging time? Okay, if it was 5 hours longer than the driving time. Okay, so the jogging time is 5 hours longer than the driving time. So the time of jogging equals, it's going to be 5 hours longer than the driving time. So you're going to put what? Time of driving plus 5, right? Okay. So now we need the distance, right? Well, look at the picture. What's the distance? Equal, right? Okay. So that's all we need. So we're not going to write D, of course. Don't forget. You're going to write the distance jogging is rate times time jogging. And the distance driving is rate times time driving. Oops, I got too happy there. That's all we need. And there we go. We just stick it in there and we solve it. Boom, there you go. Okay, I won't bother to do that. Okay, well, let's do a slightly different one. And drawing a picture of these really helps if you want to do that, if you're a visual learner. Don't forget, if you need to scratch the screen, like go up to YouTube and just scratch the screen and sniff it. If you're a nasal learner, that'll help a lot. Okay. Kermit the Frog hopped onto a southbound bus at 9 a.m. So here he is. He goes onto a southbound bus. Okay. He goes onto the bus. All right. That's Kermit going this way. 2 hours later, Big Bird left from the same spot on a northbound bus. There they go. If the buses traveled at the same rate, that's helpful. They were 352 miles apart at 2 p.m. How fast did they go? Well, this is interesting. They are 352 miles apart, which means all the way from here to here. Let's say this is Kermit and this is Big Bird, and they're 352 miles apart. Okay, well, that's helpful. Will you tell me what equation can we write with Kermit and Big Bird, their distances together is 352 miles? How could you write that as an equation? Like the distance of Kermit plus the distance of Big Bird is or equals 352, right? Of course, we don't use D's. What do we use? Yep, R's and T's. Okay, so there's the distance of Kermit, right? We don't know what it is. We do know that if you add it to the distance of Big Bird, it's that. Okay. All right. So let's talk about, okay. Let's see, they traveled at the same rate. Ooh, helpful. Okay, how can I write that as an equation? You tell me. The buses traveled at the same rate. I'll start you off. The rate of, yep, Kermit equals the rate of Big Bird. There we go. Okay. You could have put S for southbound and N for northbound. It doesn't matter, whatever you want. So we have a distance, we have a rate, now we need time. He leaves at 9 a.m. and he goes until 2 p.m. So how many hours is it from 9 a.m. to 2 p.m.? So the time of Kermit is 5 hours, right? 2 hours later, Big Bird left. Okay, so we know the time of Big Bird is 2 hours later, or, 11 a.m. to 2 p.m. is 3. Or you could just do 2 hours later, 2 hours less than 5 is 3. And there you go, that's it. Let's figure it out. So the R sub k, I'll just put R, I'll just put R sub k times T sub k. That equals 5. I'll just stick that in front because we're multiplying, doesn't matter what order. R sub b, well, we don't want to have an equation that's R sub b. So if it tells us it's the same as R sub k, we just need to put R sub k there, right? The time of Big Bird, we figured out was 3, right? And that equals 352. Well, 5 of that plus 3 of that is 8 of that. And if we did the division, we would find that the rate of Kermit is 44. Now they're asking how fast the buses go. Okay, well, fine. We got to find the rate of Big Bird too, which means we got to figure this out. Okay. If the rate of Kermit is 44, we just plop it in there, here, right? So in other words, 44 is the rate of Kermit times the time of Kermit, that's 5, we said that, plus the rate of Big Bird, we don't know. We know the time of Big Bird is 3, so 3 times the rate of Big Bird is 352. So 44 times 5, we can do that, is 220, plus 3 times the rate of Big Bird is 352. Did I do that right? Okay, looks like I didn't do that right. Well, maybe I did. Okay, the rate of Big Bird is 352 minus 220, which is 132. Oops, that should be 3, right? Okay, well, it looks like they're both 44 miles an hour. Okay, interesting. All right. The important thing is getting those 4 equations out of that. Let's look at another one. A snail starts from Bugville at 11 a.m. and heads for Ant City, 332 miles away. Well, let's do it. A snail starts from Bugville, heads for Ant City, 332 miles away. So there's Ant City. It's 332. There you go. At the same time, a roach leaves Ant City and heads for Bugville at 65 miles an hour. So the two meet. So here they are, ink, and there's one, ink, going on with that. They meet. Okay. If they meet at 1 p.m., what's the rate of the snail? Okay, well, look at this equation. You've got a snail going this way, and you have a roach. I'll just call it a roach. It's an S and an R. And it goes this way, and they meet. Okay, well, if the snail is going, and he goes to Ant City, and then the roach is here at Ant City, and they both are going at each other, and they go like that, doesn't mean they're exactly halfway. It just means they met. And it means between them two, they went how many miles? Look at the problem. How many miles together did they go if they meet? 332, right? Okay, so there it is. So we have a distance. Oop, I got it. A distance, okay? So we have a distance of the snail plus the distance of the roach is 332, right? That's how we would write that. So we don't write the distance of the snail plus the distance of the roach equals 332. Of course, we write not D, but the rate of the snail, time of the snail, plus the rate of the roach, time of the roach. And there we go. And that's, you know, that's going to be the equation we plop stuff into. Okay, so a snail starts at 11 and they meet at 1. So the snail's time, in other words, the time of the snail is 2, right? Okay, at the same time, nice. Okay, the time of the roach is also 2. Okay, now we need one last equation. Where is it? We got a time, excuse me, a distance. We got a time, we need a rate. Okay, where's the rate? Okay, the rate of the roach is 60. Good grief, everything's going. Okay, there we go. Okay, let's plop it in there. In fact, you know what? Pause it. Go ahead and pause it and then figure out what is the rate of the snail. Figure out the R sub S. Figure that out. Okay, I'm assuming you paused it. The time of the snail is 2. So I'm just going to put 2 times the rate of the snail. In other words, right there. Plus, the rate of the roach is 65. Times the time of the roach is also 2. I'll just go ahead and put 2 times 65 is 130, excuse me. That's 332. So 2 times the rate of the snail is over there. 332 minus 130 is 202. Then you just divide by 2. And that is one heck of a fast snail. There she blows, 101 miles an hour. Wow, okay. All right, and that's it. You're just trying to find those 4 equations. Keep at it. Draw pictures if you need to. Okay, here's a very practical one. A teacher and a student with a chicken sandwich, 400 miles apart at midnight, ran toward each other. So here it is. Here's the teacher. He's running this way. Here's the student. Here. Right there with the chicken sandwich. Oh, with 2 pickles on it, as all good Christian chicken sandwiches should have. There it is. They run toward each other. This teacher has a little piece of paper with the answers to the quiz and a bunch of bonus points in exchange for, you know, the chicken sandwich. Okay. So they're 400 miles apart. They run toward each other. They met at 8 a.m. Student ran, blah, blah. Okay, here we go. So first off, if they're 400 miles apart, what's the big equation that we need to write? And we don't assume, again, that they're, oh, it's 200 and 200, because we don't know that. It could be 398 and 2. Who knows? One of them runs way faster. The teacher's desperate for that sandwich. Okay. Well, we know the 2 distances together equal 400, right? So the distance of the student plus the distance of the teacher, 400. We don't use D's. Okay, we'll say rate of student, time of student, plus rate of teacher, time of teacher is 400. That's our biggie. That's what we're going to put everything into, right? Okay. At midnight, that's key. They met at 8 a.m. Okay, so you tell me what's the time of the student? Obviously 8, right? Which means also the time of the teacher is 8, okay? The student ran 20 miles an hour faster, so that's a rate, right? So the rate of the student equals, you tell me, the rate of the student equals, okay, I think I heard you say the rate of the teacher plus 8,000. That's wrong. It's the rate of the teacher plus 8. Okay. It's not 8 either. It's 20. Okay. All right, here we go. 20. It's a little darker blue. Okay, now we just plop stuff in here. All right. Well, the R sub S, we got it right here, right? R sub T plus 20. The T sub S is going to be 8. I'm just going to rearrange the order of those. So it's going to be 8 times R sub T plus 20. All right. The R sub T, I don't know, I'm not sure what it is, but it's okay. We have that as our other, you know, variable, so we got it. So R sub T is there. The time of the teacher we also know is 8. The whole thing, excuse me, is 400. All right, well, let's multiply. 8 times the rate of the teacher plus 8 times 20 is 160, plus another 8 times the rate of the teacher is 400. So I got 8 plus 8 is 16. 16 times the rate of the teacher. I'm moving this over. 400 minus 160 is 240. If this is the kind of thing, if you want to use a calculator, you're okay. It's just one of those things to save yourself some time, but you would find that the rate of the teacher is 15. Okay. If the rate of the teacher is 15, they tell you, find the speed of both. We did that. Well, how do you find the speed of the student? Well, you just go, the speed of the student is that plus 20, and the speed of the student, or rate of the student, would be then 35. And there you go. All right. I know these aren't like bone easy, oh, I can do this in my sleep yet, probably, unless you're really good at these. If you are, congratulations, that's great. If not, don't let it bug you. Draw a picture, figure out you need one of those big equations like this using a distance so you can stick stuff in there. The other little things, figure out, if they, in other words, if they don't give you like a time or whatever, just assume it's the same. Or if they, give you something like 400 miles apart, well, you've got to draw that and go, oh yeah, together that equals 400. Boom, there you go. So, and by the way, if they both go this for 8 hours, this dude's only going 15 times 8, which is 120 miles. This dude is going 35 times 8, which is 280 miles. So almost never is it the same distance or whatever. So, okay, well, let's take a look. Go ahead and pause it and try A and see what you get. Okay, this sounds like some kind of a homeschooler's name. Ukiah Grace. That would be a good girl's name for a home. Ukiah Grace. Ukiah Grace! Put down an American Girl doll. Okay. All right, an eastbound bus left Ukiah at noon. All right, well, I don't know what's going east. There it is. There is Ukiah. This bus is going east. 2 hours later, a westbound bus left the same station. Okay, well, there's a westbound bus. Okay, I don't know, I'm just drawing, random distances here. If the buses traveled the same rate for 500 miles or whatever it is apart. Okay, in other words, they are 500 apart. That's key. All right, so your first equation needs to be, you have two distances, and together the two distances equal 500. So the distance of, just call it E and W. So the distance of the E plus the distance of the W equals 500. Okay, that's the first one. All right. The eastbound leaves at noon and it stops at 6 p.m. So the time of the eastbound bus is going from noon to 6 p.m. So that's going to be 6, of course. All right. 2 hours later, which means the time of the westbound bus was 2 o'clock to 6 o'clock, which is 4 hours. Oh, excuse me. Yeah, 4 hours. They traveled at the same rate. Well, you tell me that equation. What's that going to be? Okay, the rate of the eastbound bus is the same as the rate of the westbound bus. There we go. We got it. Okay, so we just need to plop this in here. So rate of the east, I don't know, rate of the east. Time of the east, 6. We got it. There's the 6. Rate of the west, well, you don't want to put R sub W in this equation because you can't solve an equation with two different variables. So since it's the same thing, you just put R sub E again. Okay, the time of the west was 4. That equals 500. Okay, well, obviously this is 10 times the rate of the east equals 500, which means the rate of the eastbound bus is 50, right? There you go. Find the rate of each bus. Well, they traveled at the same rate. There you go. Okay. By the way, if this thing, the eastbound bus went for 6 hours, figure this out. If the eastbound bus goes for 6 hours, right, and goes 50 miles an hour, what's 6 times 50? 300, right? It goes 300 miles. This other one over here, it's going 50 as well because it's equal. So it's going for 4 hours. What's 4 times 50? 200, right? Together, there she blows. That proves we're right. So there we go. Okay, pause it and try B. Okay, a train starts from Peoria. That's a city in Illinois. And let's see, at 2 p.m. and heads for Reedley, 750 miles. Come on, no American trains go kilometers. Okay, they go miles. Good old American miles. Okay, all right. A train starts and heads for Reedley. All right, and here we go. In other words, here's the train going to Reedley, like that. Same time, a train leaves Reedley and goes this way. Okay, they crash head on for, okay, no, I don't do that. They meet. Oh, that's interesting. The trains meet? Okay. Where's the question about how many people are killed? Okay, never mind. They just meet in a friendly manner, I guess. Okay, so they meet. All right, well, if they're 750 miles away, well, that means the two distances are going to equal 750 miles. You know how to write that. All right, we'll just call them, I don't know, train 1 and train 2. I don't care. So let's say the distance of train 1, r sub 1, t sub 1, plus the distance of train 2, or yeah, equals 750. There's our biggie right there. Okay. All right, this thing started at 2 p.m. and it meets at 5 p.m. So the first train, oops, that's not a P, that's a T. The time of the first train is from 2 to 5. That's going to be 3. The time of the second train, at the same time, so that's good. That's also 3. Now we need a rate. Okay, the second train, 85. Wrong. Miles, good old miles. The rate of the second train is 85. Okay, we got it. We got our 4 equations. That's all we need. But do you see, look at this. You've got 1, 2, 3, 4 things you don't know. There's the answer to 1. There's the answer to the second. There's the answer to the third. We got it because we just plop them in, right? Okay, so r sub 1, we don't know, of course. That's what they're asking for. T sub 1 is 3. So 3 times the rate of the first train plus, that's also 3. 3 times 85 is going to be 750, right? All right, so 3 times the rate of the first plus 3 times 85 is 255. That equals 750. And we just subtract 3 times the rate of the first equals 750 minus 255. And that's going to be what, 495? Is that right? That seems huge. Good gravy. Okay, well anyway. 3 times the rate of the first train, we'll just divide then. 3 into 49 is 16, 165 miles an hour. That's a heck of a fast train. Anyway, okay. That should do us. And don't worry if you don't get these all right away. These are all, they've thrown in a couple of different types. If it takes a few weeks or even a few months, that's fine. If you have to stay up all night long for 2 weeks in a row without sleeping or anything like that, go ahead and do it. Just tell your parents you can't do the dishes until August because you have to do your math and stuff. Anyway, okay, good luck on those. See you guys next time. Take it easy.